All right. So some questions were asked about 3-2, the assignment you graded when the sub was here. I got them listed here, number 16, 19, 20, 25, and 30. So we'll go ahead and go through them. For both 16 and 19, and all the ones in this section, 11 through 19, there's two key pieces of information you have to get from the directions. And that is that the measure of angle 11 is 62, and that the measure of angle 14 is 38. You also need to pay very close attention and notice that these two horizontal lines here are parallel to each other. The other two lines are just going to be transversals based on whatever angle you happen to be looking at. Now, number 16 is focusing on angle number 2. Now, this is a particularly difficult problem, so I'm not surprised people had trouble with it, because it itself is not a single angle on, it's not touching the parallel line directly. So it's a little bit harder to see what's going on. I am going to add in a couple of pieces of information. I know measure of angle 11 is 62 degrees, and measure of angle 14 is 38 degrees. And what that's going to do is it's going to help me build some things. Uh, Mainly, I'm going to have to use both of these angles together. If you take a look here, I got the two parallel lines, and in red, I'll draw out a transversal. Now, with that transversal, 14 and 6 are corresponding angles. So 14 and 6 are corresponding. That means they have the same angle measure because they are congruent. So this is also 38 degrees. So that if I'm having to list my properties that I'm using, the first one I'm going to use is corresponding angles. And if you want to be specific, you could say 14 and 6, but I'm not going to do that here. Up next, I'm going to do that with 62 as well. This time I'll draw a green line. So now look at the green transversal, and 11 and 4 happen to be corresponding angles as well. So for 4, I'm going to write 62 degrees. Now, one thing, if you had redrawn or sketched out this picture here that was in the book, you actually are creating something that's pretty useful because there's all these angles that you can use, right? Had I been doing this from the beginning, you might have actually already done one of those things in a problem, and that would have been one less step to do. And since I didn't use it, I used corresponding angles again. I just left that there as my property to use. So now I'm going to erase those two things. Because now I notice here I'm going to draw this parallel line red here. I've got two of the angles along the bottom, but I'm missing that third angle. But I notice angle 2 and angle 5 are vertical angles, so they're congruent to each other. So if I can figure out what angle 5 is, then I can figure out what angle 2 is. And I can figure out what angle 5 is because 4, 5, and 6, they're all supplementary. Measure of angle 4 plus measure of angle 5 plus measure of angle 6 all add up to 180. And I know what 4 is, it's 62. And I know what 6 is, it's 38. So add 38 and 62 together, that's measure of angle 5 plus 100 equals 180. Ooh, subtract 100 from both sides. Measure of angle 5 equals 80. Well, measure of angle 5 right here, that equals 80 degrees. How did I find all of that stuff right there? Well, that's just supplementary angles. You could say linear pair, though it's really a linear triple. Supplementary is just fine right there. But now I know angle 2 and angle 5 are congruent to each other because of vertical angles. So the measure of angle 2 equals 80 degrees. angles. All right. It looks like I need some more space to do number 19. Number 19. So let me box this, and if you wanted to, you could highlight vertical angles, corresponding, and supplementary. There we go. All right, number 19. Measure of angle 1. Well, let me erase some of this stuff here, but you notice I'm not going to erase, well, this is 80 here. We did all that work. We're not going to erase the 80s or the 38s or 62s. So what I want you to notice here, as we build this problem and we answer more questions, we get more and more information, becomes more and more complete. If you know 14 and 6 are both 38 because they're corresponding angles, well, you might notice that 1 and 6 make a vertical angle. So those should be congruent as well. So how do I figure this out? Measure of angle 1 is 38 degrees because corresponding angles, that got me from the 14 to the 6, and then vertical angles from the 6 to the 1. So angle 14 to angle 6, angle 6 to angle 1. You don't really need this column of information here, but I thought that might help. Because that one moved a lot faster, right? No calculation to do there. And part of that was because I already had figured out a bunch of stuff. As you go along with all of these problems, if you were doing them and writing them on the picture, then you would have filled out a lot of information and it might have been easier to spot what was going on. But independently, it can take some time. All right. Number 20. This is a very similar kind of problem. We got a solar dish here. We're assuming all of the light rays coming in from the sun are parallel to each other, which is a pretty good assumption. They're not exactly, but I mean it's basically they're parallel. Um, Determine the relationship between each pair of angles and explain your reasoning. So when it says determine the relationship, we're trying to figure out, are they corresponding, alternate interior, alternate exterior, consecutive interior, which one of the 4 vocab verbs do we have? Or even vertical angles maybe. And number 20 is asking us about angle 1 and angle 2. So I'm going to do 2 things. I'm going to take a look and see if I can spot where angle 1 and angle 2 are. All right. And I'm going to try to identify the parallel lines that are touching those 2 angles. And you can see I'm highlighting those in red there. So those are the parallel lines. Those are the sun rays. Now, with all of these things we've been doing, if they're not all, both on the same line, if they're about parallel lines, we have to have a transversal as well. So I'm going to highlight the transversal in green. That line is also touching both of those angles. And now you can see, I'll draw it out a little bit separately here. You've got 2 parallel lines and a transversal. Angle 2 and angle 1 are in between the parallel lines and on the same side of the transversal. This would tell us they are consecutive. Consecutive interior angles. And that should also tell us that they're supplementary, right? They add up to 180 degrees. Doesn't matter what they are, they add up to 180. All right, and that's all I'm really looking for here. I explained our reasoning. My explaining the reasoning would be kind of what I was saying before. They are on the same side of the transversal and between the parallel lines. I think after as many years as I teach math, I would spell parallel correctly. But there you go. That would be my reasoning. Number 25. I believe our goal here is just to find the values of x and y. So to do this, I'm going to do a couple things. I'm going to take a look and see where my variables are and see where I have relationships that I can use. So I notice I have an x on the left and a y on the right and a nice number on the bottom left. So I'm going to try to use the bottom left because that gives me an expression with no variables. So I'm going to try to see if it has a relationship to the x expression or the y expression. And for the y expression, they're on alternate sides of the transversal. So you might think, oh, maybe it's alternate interior, alternate exterior. But you might also notice, that 105 is on the exterior, but y plus 25 is on the interior of the parallel lines. So there's actually no direct correlation between those two expressions. Now let's check for the x. 105 and the 3x minus 15. Those are both on the bottom left of the intersections of the parallel lines of the transversals. That tells us these two pairs of angles here are corresponding angles. Corresponding angles are congruent. So their measures are equal. Add 15 to both sides. 120 equals 3x. Divide both sides by 3. 40 equals x. Then use the symmetric property. All right. Okay, so that's my x. Now, I said before I can't use the 105 in the y plus 25, and that's still true. But now I have a value for x. What's the actual value of this expression here in this angle? Well, it's corresponding, so it should be 105, right? They should be equal to each other. 3 times 40 is 120, minus 15 is 105. So now I know this angle here is 105, and now I have a linear pair, two angles making a straight line. So those two angles should add up to be 180. So 105 plus the other angle, y plus 25, should add up to be 180. 130 plus y equals 180. Subtract 130 from both sides, and you get y equals 50. And that's all you need to do. So with these, it's always like, what kind of relationships can I set up? And remember, it's always going to come down to they're either congruent, so their measures are the same, or they're supplementary, so their measures add up to 180. It's going to be one of those two options. You just have to figure out your reasoning for why it's one of those two options. Technically, I guess it could be a third one where they add up to 90, but it's the same kind of thing. There's got to be a reason why it adds up to 90. Last one, number 30. Just so you know, Algebra 2 had one question. The video was longer than this. It was a hard question, and I made a mistake in it, which made it even longer. Number 30. We're going to copy and complete the proof. But basically, let me turn off my webcam here. Basically, the idea is I'm given some stuff, I'm told what to prove, and I've got some incomplete steps along the way. I'm, of course, going to use this diagram on the right, so let's go ahead and check to see what's going on here. Given M and L are parallel to each other, that's what the double bars mean. So M and N are parallel. Okay, I could see that from the red marks there. That's good. L is a transversal. Okay, yep, that's a line that cuts both those parallel lines. That seems like that's all in the picture. And everything else, the 1, 2, 3, 4, 5, 6, 7, 8, all of that stuff looks like it's just labeling, so I can refer to all of these things a lot easier than, having to give each one of them a 3-point name. My goal is to prove that 1 and 2 are supplementary. So I want to show that 1 and 2 are supplementary. That means they have to add up to 180. Okay. And also I'm trying to prove that 3 and 4 are supplementary. Same thing, that means they add up to 180. All right. So at some point we're going to be using um, something about uh, parallel lines, probably corresponding angles. And if you notice here, it says you're writing a proof of theorem 3.2. And if I go to the book, let me move the book down in here. If I go to the book, I bet um, theorem 3.2 consecutive interior angles theorem. This is what I'm trying to prove. Consecutive interior angles are supplementary. But I can't use this theorem to prove the theorem. I have to go back and use something before it. So I'm going to go back a little bit further. And it looks like the only thing I get to use is the corresponding angles postulate. So that should be something that gets used at some point inside of the theorem. Otherwise, everything else should just be like stuff is adding up to 180. And it's getting manipulated that way. So, A, given. Well, what are we given? I mean, it tells us right here. We're given M is parallel to N, semicolon, L is a transversal. All right, pretty easy. They tell us what's given right there. 1 and 3 form a linear pair. Well, you can see here 1 and 3, they're both on the same line. And that makes sense, right? It's one line cut into two pieces. That's a linear pair. And it says the same thing for 2 and 4. Yeah, linear pairs, they're formed that way. How do I know that? Well, that's just the definition of linear pairs. All right? Now, C. If two angles form a linear pair, which was what part B said, then they are supplementary. So what that's saying, what I'm trying to show there is, since 1 and 3 form a linear pair, then they should add up to 180. So I write measure of angle 1 plus measure of angle 3 is 180. And I would do the same thing for measure of angle 2 and the measure of angle 4. They add up to 180 as well. Now, angle 1 and angle 4 are congruent to each other. That's what it says. Angle 1, let me erase the black here. Now it's telling me that angle 1 and angle 4 are congruent to each other. Also that 3 and 2 are congruent from each other. When I take a look at that, that is, they're on alternate sides of the line, and they're on the interior of the parallel lines. Sorry, the alternate sides of the transversal, and on the interior of the parallel. So that makes me think alternate interior. But I can only use that if that's theorem 3.1. So let me go back to the book here and take a look. Is alternate interior angles 3.1? Alternate interior angles theorem 3.1. Yes, I can use it. So that's what I would use. And go back here. Alternate interior angles theorem. Now, do you need to know that it's angle 3.1? No. Do you need to know the name of it? Yes. Do you need to know what it means? Yes. That's all. You don't need to know the 3.1, 3.2. That stuff's not useful. Because if you use a different book, it doesn't matter. All right. Okay, so we got those angles are congruent. That means that their measures are all equal. That's the definition of congruence. Nice for them to fill that out for us. We got to get to our final step. We got to say that 1 and 2 are supplementary and 3 and 4 are supplementary. So that almost tells us what our line should be. Measure of angle 1 plus measure of angle 2 equals 180. Measure of angle 3 plus measure of angle 4 equals 180. That's what I want it to be. That's what I'm trying to prove. Now I just have to think about what justified us combining, I'll give you a hint here, line C and line E together. If you take a look here, 1 1 and 3 add up to 180. 1 and 3 add up to 180. Angle 2 and angle 3 are the same, and I substituted it in. Oh, that's all it is. Substitution. Measure of angle 3 and measure of angle 2 are the same, so I just swapped out the measure of angle 3 for measure of angle 2 in the first sum of 180. Then I did the same thing with 2 and 3 in the second equation. And I got angle 3 and angle 4 out of 180. Nice. There we go. That's the proof.